Here we are, Math 1, Practice 2.4.2, Proving Average Rate of Change. So, we're going to calculate the rate of change for each scenario described. The Beechcraft 1900D is a commuter airplane with a fuel capacity of 665 gallons. The function for the situation is f of x equals negative 0.9x plus 665, where x represents miles flown, and f of x represents the amount of fuel remaining. What is the rate of change for this scenario? So, rate of change, remember, that deals with, for linear, that's your slope. For exponential, it's the slope of a line connecting the 2 points. It's kind of different for exponential. So, we've got our function here. So the growth, the slope, is the one with x, so negative 0.9. But what does that mean? Well, it means we lose the negative 0.9 gallons of fuel for every 1 mile that is flown. Okay, so number 2, the velocity of a ball thrown directly upward can be modeled by the function negative 32x plus 96, where x represents the time in seconds and f of x represents the height of the ball in feet. What is the rate of change for this scenario? Okay, so that negative 32 is our slope, right? And we go negative 32 over 1, so that's the average rate of change. The top number is like the f of x, so that would be the height. And x would be time in seconds, so it'd be a negative 32 height feet, right? Negative 32 feet of height every 1 second. Alright, number 3, an investment of $900 is invested monthly at a rate of 4%. The function that models this situation is f of x equals 900 times 1 plus 0.04 divided by 12 times 12 to the x, where x represents time in years. What is the rate of change for the interval 310? Now, see, this is exponential, right? Because we can see that exponent. So what we have to do is we have to find what happens at 3 and what happens at 10. Okay? So we'd go 900 times 1 plus 0.04 over 12 times 12 to the 12 times 3. Okay, plug 3 in for x. We figure out what that means, and we figure out what the 10 means, and using that, we find the difference. So I would just put this into my calculator. And then that gives us 1014 point, and we're dealing with money, so probably just round to the nearest hundredth, 54. Okay, then we do the same thing, but instead of 3, I use a 10. So I'm going to do the same thing, but instead it'd be 12 times 10. Okay, that gives me 1341.75. Okay, so graphically the way to think about this is our graph is going up. So at 3, we're at this point, and then at 10, we're up here. So it's like we're making a line here, and we're finding the slope of that line. So the difference here when we subtract these two is 327.21. The horizontal difference, 10 minus 3, is 7. So we go 327.21 over 7. We simplify that, and we get 46.74. That is our average rate of change on that interval. Okay, number 4 is similar. So the price of stock started out at $150 per share and has declined to 75% of its value every 2 weeks. The function that models this decline is f of x equals 150 times 0.75 to the x over 2, where x represents time in weeks. What is the rate of change for the interval 1 to 4? So I go f of 1, okay, and then it'd be 1 over 2, and then I'm going to do f of 4, right? Using a calculator, I'll do the same thing, 4 over 2. Then I'm going to figure out what they are using my calculator. Then for my slope, remember it's always the y over x, so f of x over x. The x difference, 4 minus 1, would give us 3, right? So the bottom is 3. So then I need to figure out these numbers. So 150 times 0.75 to the 1 divided by 2, 1/2. I get 129, and I'm dealing with money again, so round at the nearest hundredth, 129.90. Then I do it for 4. I get 84.38. Okay, so then I'm going to take 84.38 and subtract 129.90 because 84 is further along. And this is declining, so it should be negative, should be going down. So we get negative 45.52, which then we divide that by 3, and we get negative 15.17 or 0.18, depending on how you round it. Alright? Okay, number 5 says, the table below lists common Celsius to Fahrenheit degree conversions. What is the rate of change for this function? Okay, in other words, how is this growing? Well, this is going up by 10, right? So if we make that slope, that would be 10. The other one, 32, is going up by 18. We're adding 18 each time. So it'd be 18 over 10, which we can reduce that, dividing them both by 2 to 9 over 5. So our rate of change is 9 over 5. And it's positive because they're both positive. Alright, number 6. Okay, so the table represents a total cost for a cell phone plan. Use the table to answer questions 6 and 7. Okay, what is the rate of change for this function over the interval 250 to 1000? So where's 250? Right here. Okay, 1000's right here. So what's our x difference? Well, 1000 minus 250 is going to be 750. So our fraction, that goes on the bottom. Then on the right side, how is this one growing from that same interval? So 55 to 115. So 115 minus 55 gives us 60. So 60 goes on the top. Okay, so then 60 divided by 750 gives us 0.08. So that's the rate of change, 0.08. Okay, number 7, we've got the interval 250 to 750. So 250 to 750 is a difference of 500 here, right? And then it would be 75. Oh, let's erase this. It would then be 55 to 95, which would be 40. So I'd go 40 over 500, and then we reduce that. And it also gives us 0.08. Okay, which probably tells us this has a constant rate, which means it's probably linear. Okay, number 8. A petri dish starts out with 15 bacteria. The number of bacteria doubles every 2 minutes, so we should be able to see doubling. That's multiplying, exponential. Use the table below to calculate the rate of change from interval 24 to 48. So 24 to 48, okay, that's a difference of 24. We add a 24. And then we do their f of x values, their outputs, 60 to 240. That's a difference of 180. So I go 180 over 24, and then I see what that becomes. 180 divided by 24 gives me 7.5. So that's my average rate of change on that interval. Okay, in other words, this would be exponential, so from this point of 24 to 48, if I made a straight line, its slope would be 7.5. Every time it goes over 1, up 7.5. Okay, now the table below represents worth every 2 years of an initial investment of 500 that earns 2.6% interest compounded quarterly. Use the table to answer the questions. So, interval from 0 to 4. So 0 to 4, we have a difference of 4 years. and then 500 to 554.61, difference of 54.61. So I make my average rate of change 54.61 over 4. Type it in my calculator. That gives me 13.65 when we round, since it's money. Okay, then let's do it for 2 to 8. So 2 to 8, that's got a difference of 6. 526.60 and 615.19 has a difference of 88.59. So I go 88.59 over 6, and I see what that gets me. Gets me 14.77. Okay. Notice up here, even though we had two different intervals, they had the same. That's constant. That would probably be a linear function. Okay. Whereas if we go down here, it's exponential, and notice over intervals we have different numbers. Had those been a linear equation, they would have been the same. And there we go, guys.